Linear motion in one direction. The direction of vector quantities can be better described by designating a coordinate system within the reference frame. This is a simple coordinate system consisting of a one-dimensional coordinate line. In general, when describing horizontal motion, motion to the right is usually considered positive, and motion to the left is considered negative. With vertical motion, motion up is usually positive and motion down is negative. In some cases, however, as with the aeroplane, it can be more convenient to switch the positive and negative directions. For example, if you are analyzing the motion of falling objects, it can be useful to define downwards as the positive direction. If people in a race are running to the left, it is useful to define left as the positive direction. It does not matter as long as the system is clear and consistent. Once you assign a positive direction and start solving a problem, you cannot change it. It is usually convenient to consider motion upward or to the right as positive, plus, and motion downward or to the left as negative. A person's speed can stay the same as he or she rounds a corner and changes direction. Given this information, is speed a scalar or a vector quantity? Explain. Speed, velocity, and acceleration. Motion is one of the most noticeable properties of most of the objects that we observe around us. We can use a number of terms to describe the motion of a motor vehicle. Terms commonly used include speed, velocity, acceleration, and distance. The everyday use of these terms is often different from the scientific usage. For example, most people use the words speed and velocity to mean the same thing, but to a scientist the two terms have slightly different meanings. Speed. Speed can be thought of as the rate at which an object covers distance. If an object covers a given distance in a very short time, we say that it has traveled at a very high speed. Speed is the rate of distance moved with time. Speed equals distance over time. The common symbol for speed is v, but sometimes, even s is used. The SI unit for speed is meter per second, m/s or ms power, -1. The time involved should be very short unless we desire to calculate average speed. A car traveling from Mons to Lusaka, a distance of 200 kilometers, cannot maintain a constant speed because of roadblocks, potholes, and hills. If the car takes 2 hours to cover this distance, its average speed is, average speed equals total distance, divided by, total time, equals x by t. Where x stands for distance, t for time. S equals 200 kilometers over 2 hours equals 100 kilometers per hour. Changing kilometers to meters and hours to seconds, we have, speed equals 100 kilometers times 1000 meters/kilometers, over, 1 hour times 3600 seconds per hour, equals 27.78 meters per second. When we talk about an object's speed, we have no idea about its direction. So speed is a scalar quantity. Velocity. A body may move in a straight line, a circle, or any other path, but as long as it covers the same distance every second, it is said to move with constant, uniform, speed. If it covers a certain distance in a specified direction, that distance, which includes direction, is known as displacement. Displacement is defined as the distance moved in a specified direction. Velocity is the rate of change of displacement with time, and it involves the idea of direction. While speed describes only how fast an object is moving, velocity gives both how fast and in what direction the object is moving. If a car is said to move at 60 km per hour to the north, its velocity has now been specified. To have constant velocity, an object must have a constant speed in constant direction. Constant direction constrains the object to motion in a straight path. The object's path does not curve. Thus a constant velocity means motion in a straight line at a constant speed. If there is a change in speed, direction, or both, then the object is said to have a changing velocity and is undergoing acceleration. The SI unit of velocity is the same as the one for speed, meters per second, and the symbol of velocity is v bar. The velocity of a car can be found at a particular moment, and this is called the instantaneous velocity of the car. Instantaneous velocity equals small distance traveled in stated direction, over, small time taken. As with speed, we can also use the term average velocity to describe the motion of an object like a car. Average velocity equals change in displacement, over, time taken, equals x by t. Where, delta, represents change in i.e. t means change in time. The speed and velocity of a car is sometimes given in kilometers per hour, km/h or kmh power minus 1. 1 kilometer per hour equals 1000 meter, over, 60 times 60 s, equals 1 over, 3.6, meters per second. i.e., 1 metre per second equals 3.6 kilometers per hour. Example. A car travels from one city to another 96 kilometers away in 1.2 hours. What is the car's average speed in kilometers per hour and meters per second? Answer. Average speed equals distance covered, over, time taken, equals 96 over, 1.2, equals 80 kilometers per hour. 80 kilometers per hour equals 80 meters per second, over, 3.6, equals 22.2 meters per second. Acceleration and deceleration/retardation. Objects rarely move at a constant velocity. In most cases, the velocity of an object constantly changes in magnitude or direction or both. In such cases, the object accelerates. Acceleration is the rate of change in of velocity with the time, and it can be stated as follows. Acceleration equals change in velocity, over, time taken, or, v bar, over t, where v is the change in velocity and t is the time. The symbol for acceleration is a bar. V equals vu, where u stands for initial velocity and v stands for final velocity. Hence a equals vu, over t. The SI unit for acceleration is meters per second squared or meters times second power, minus 2. To change the velocity of a body and hence produce acceleration, we only need to change its speed or the direction of the motion or both. When the body's velocity is reducing, this rate of change of velocity with time is called retardation or deceleration. Examples. A train increases velocity from 6 meters per second to 10 meters per second in 2 seconds. Find its acceleration. Answer. Data, initial velocity, or u bar equals 6 meters per second, final velocity, or v bar equals 10 meters per second, time, or t equals 2 seconds. 2. A car traveling at 20 meters per second slows down to 10 meters per second. Find its acceleration. Answer. Data, u equals 20 meters per second, v equals 10 m/s, t equals 2s. Exercise. A car accelerates at a constant rate from 40 km per hour due east to 90 km per hour due east in 5.0 seconds. What is its acceleration? A runner starting from rest reaches a velocity of 9.6 meters per second in 2.0 s. What is her average acceleration? What is the velocity of a runner who runs 96 meters due north in 12 seconds? To learn more on this topic, please open the link in the description to access the free course. Thanks for your attention. Kindly like and share our videos. Please don't forget to subscribe and press the notification bell to be the first to receive the next learning video. You may also give us a comment to suggest what topic you would like us to cover. See you later.